how a heartbeat becomes a graph node. The big picture first. The creature has one source of truth, a graph database called Neo4j. Every memory it has lives there. Concepts, conversations, facts, episodes, basins, all of it. Nodes connected to other nodes. But here's the rule. Almost nothing is allowed to touch Neo4j directly. There is one door with one doorman, and everyone has to go through him. The doorman is called Graphiti service. Why? Because if every agent could scribble into the database becomes incoherent in about a week. Same name spelled three ways. Duplicate concepts, lost relationships. So instead, you have a protected room with a single entrance. In the docs, they call this a Markov blanket. Memory-pipeline.md:13 to 36. Fancy term, simple meaning. A thing with a clear inside, a clear outside, and a small fixed set of doors. You can only get in or out through the doors. Big picture. This is the same pattern again. Sockets, gates, narrow doors. Last time it was the referee plug, the brain plug. This time it's the memory plug. The system is consistently designed as narrow doors with strict rules. The four workers in the protected room. Inside the memory blanket, there are four characters. Watch them in order. 1. The router. What kind of memory is this and where does it belong? Memory basin router .route_memory is the front desk. An agent walks in holding some text and says, I want to remember this. The router does two things. Classifies it. Is this a fact, semantic, a how-to, procedural, an event in time, episodic? Picks a basin for it. A basin is a themed cluster, like a filing cabinet drawer. Things about the same concept get pulled into the same basin by a magnet. A Hopfield network, but you don't need that detail today. Think of basins as gravitational attractors for related ideas. Big picture. A basin is the closest thing in the system to what the creature is thinking about right now. When new content comes in, it's pulled toward whatever basin it most resembles. That's what gives the system thematic coherence across heartbeats. The router also fires an event. Experience of the system, know something happened. 2. The adapter. No pre-chewed food allowed. The router hands the raw content over to MIM Evolve adapter. The adapter has one rule, and the docs are emphatic about it. Line 107. Send raw content. Do not pre-extract entities. Let the pipeline do the extraction. This is a real lesson, hard one. If you try to be helpful and pre-process the text, oh, here are the entities I found. Here are the relationships. You corrupt the extraction pipeline. The pipeline is good at finding entities if you let it see the original text. Predigestion poisons the well. Big picture. This rule appears in your Claude.md2. It's called the MIM Evolve Protocol, and it's marked as anti-poison. The system is built to learn from raw experience. The moment you start helping by chewing the food first, the system stops learning correctly. The adapter passes the raw content through to 3. The doorman, the only one with the keys. Graphiti service is the only object in the entire codebase that's allowed to talk to Neo4j. It does the actual extraction, uses an LLM to pull out entities and relationships from the raw text, and writes them to the graph. One detail worth knowing because it's elegant. Every fact written gets 2 timestamps, line 146 to 151. Valid_at, when this became true. Invalid_at, when this stopped being true. Or none if still true. This is called bitemporal. It means the system can answer questions like, what did I believe about X yesterday? Not just, what do I believe now? Big picture. This is a quietly profound design choice. Most systems overwrite old beliefs with new ones. Bitemporal memory keeps the history. The creature can disagree with its past self and remember why. 4. The editor. Turn the diary into a chapter. Nemori Riverflow is different. The first 3 workers handle individual memories one at a time. Nemori waits until enough events have piled up, then asks, did something meaningful just happen across this stretch of time? If yes, the docs call this boundary detection. Nemori distills the stretch into facts. Here's what was learned in this episode, and routes those distilled facts back through the system to be remembered as crystallized truths. Big picture. The first 3 workers are the diarist. Nemori is the editor. The diarist writes everything down. The editor reads the diary and decides what becomes a chapter. This is also where the surprise/learning signal from Spec 043 enters. Surprising episodes get distilled into lessons that future heartbeats will read back. How this connects to the heartbeat lap you just finished. Remember the very last step of the heartbeat? Run_post_cycle_background and finalize_cycle? That's where the heartbeat enters the memory pipeline. Specifically,
oh, it's about to get good? That's some geek shit to say. For real, for real. But it is.
the full S1 plus arbitration plus S2 trajectory becomes a trajectory ingestion through MIM Evolve adapter.ingest_trajectory, step 5 in the doc. The MIDCA phase trace, perceive, to interpret, to eval, to intend, to plan, to act, gets persisted via the cycle memory bridge. Surprise gets scored. If high enough, it bumps the basin's activation, which biases what the next heartbeat will see when it asks, what should I be thinking about? So the loop closes, heartbeat to memory to next heartbeat, reads memory to next heartbeat is shaped by it. Your full lap now extended. A heartbeat fires. The creature checks consent and boundaries. Fast brain looks. The referee gates. If needed, slow brain plans through a swappable provider. The result gets safety checked. Then the entire trajectory enters the memory blanket. The router classifies it and picks a basin. The adapter forbids predigestion. The doorman writes it to Neo4j with bitemporal stamps, and the editor will eventually distill the episode into lessons. The next heartbeat reads that memory. Repeat. That's the full creature, end to end. 3 patterns you've now seen 3 times. Narrow doors/sockets, referee to providers, slow brain to providers, memory to graffiti service. The codebase is aggressively gated. The loop watches itself. Phase trace, surprise, episodes, lessons. Every cycle teaches the next. Don't pre-chew. Raw content over pre-extracted. Trust the pipeline. You'll see this same instinct in Spec 043. Send raw trajectories, not pre-digested ones. The lap is complete. Good places to come back for detail. The basin/hopfield part, API/services/attractor_basin_service.py, if you want to understand the magnet that pulls related concepts together. This is where what is the system thinking about gets its physics. The cycle memory bridge plus MIDCA registry, if you want to understand how a cycle becomes an episode. The Nemori editor, if you want to understand surprise to distillation to lesson. What do you want to ask now that you've done the lap?
Let's see. I still got writing to do. I gotta see if I can extract a simpler version. Just for like situations where it doesn't need to do all this. I guess that's the system one. Let's stop right there. Or not. I'll stop here then. It's not gonna take it. You know what? I'm gonna go to the, where is it? Studio. It might not work how I'm thinking. Yeah, I don't have it in me right now. Let me go back and just empty this out again. Hold on, I think I missed some. No, actually I didn't. Okay, good.
How a cycle becomes an episode. The big picture first. You already know two things. The heartbeat does 6 labeled steps inside one tick: perceive, interpret, eval, intend, plan, act. Those names are MIDCA's vocabulary. OODA is the 4-step version. There's a memory pipeline that turns content into graph nodes, but only through narrow doors. The piece you haven't seen yet is the bridge between them. Something has to take the 6 labeled steps from one heartbeat and package them as a single episode before handing them to the memory pipeline. That bridge is the cycle memory bridge, and the thing it bridges from is the mid-cap phase registry. Big picture. A heartbeat without this bridge would just be a stream of disconnected events that happen to land in memory at the same time. The bridge is what makes the system say, this whole stretch of activity was one thing. Remember it as one thing. Part 1. The registry is a clipboard. Mid-cap phase registry is the simplest possible thing. A clipboard the heartbeat carries with it for the duration of one tick. The life cycle is 3 calls: start underscore cycle, open parenthesis, cycle underscore ID, close parenthesis, open parenthesis, line 191, close parenthesis. At the very top of the heartbeat before anything else. The clipboard gets a fresh page. Record underscore phase underscore output, open parenthesis, quote, perceive, quote, comma, dot, 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 close parenthesis. Then, quote, interpret, quote, then, quote, eval, quote, etc., as each phase finishes. Each call stamps a row on the clipboard. Finalize underscore cycle, parens, at the end. The clipboard page is detached, becomes a finished MIDCA cycle trace, and any callbacks that were registered get fired. You saw all 3 of these calls when we walked through run decide earlier. They're the record mid-cap phase lines and the finalized cycle at the end. Big picture. This is a write-as-you-go design. The heartbeat doesn't try to assemble the trace at the end. It just stamps each step as it happens. By the time the heartbeat finishes, the trace is already 95% built. Finalize underscore cycle just signs and dates it. The phase mapping is hard-coded, line 59 to 91. 2 interesting details. Interpret and eval both map to OODA's orient phase. Intend and plan both map to OODA's decide. So midcap is just OODA with finer granularity. 2 phases per OODA step where there's interesting work to do. Interpret has a convergence underscore gate equals true flag. If a separate service called linoss is active, the registry will pause at interpret until linoss signals, "I finished thinking." Times out after 2 seconds and continues anyway. This is a hook for plugging in slower, convergence-based reasoning without breaking the loop's rhythm. Part 2. The bridge is the courier. When finalize_cycle fires, every registered callback gets called with the finished trace. The most important callback is cycle memory bridge.on_cycle_complete. It does 4 things in order, and all 4 are best effort. Failures don't break the heartbeat. Step 0. Snapshot. Line 96 to 100. Add the trace to a small in-memory ring buffer called cycle history. This is for fast lookup during the next few heartbeats, before the memory pipeline has fully written things to Neo4j. Think of it as a sticky note on the desk while the filing cabinet processes the official copy. Step 1. Ingest as trajectory. Line 102 to 108. This is the main act. The bridge converts the MIDCA cycle trace into a trajectory data and hands it to MIM Evolve adapter .ingest_trajectory. The conversion is direct, line 134 to 184. Each MIDCA phase result becomes one trajectory step. The cycle's overall description becomes the query. Achieved goals become part of the summary. The cycle_ID becomes the trajectory's ID with tags MIDCA, cognitive_cycle, cycle_ID. It's also deduplication guarded. Line 103. The bridge keeps a set of cycle IDs it's already ingested. If the same cycle somehow tries to enter twice, parallel callers, retries, the second call is a no-op. Big picture. This is where one heartbeat literally becomes one episode in the graph. One trajectory ID, one narrative, 6 steps. The bridge is the moment the verb had a cycle becomes the noun, an episode. Step 1b. Persist goal predicate facts. Line 110 to 116. For any goals that ended this cycle, achieved, abandoned, delegated, write a fact to Graphiti like goal X was achieved at time T. This is so a future heartbeat's goal monitor can ask, have I tried this goal before? Did it work? Step 2. Update the goal graph. Line 118 to 122. For each achieved goal, mark it achieved in MIDCA goal graph. Critical side effect. Marking a goal as achieved triggers Attractor-Basin service .strengthen_basin, parens. The basin tied to that goal becomes a slightly stronger magnet. Big picture. This is the closing of the learning loop. Achievement leads to basin strengthening, leads to next heartbeat is more likely to be drawn into that basin, leads to more likely to pursue similar goals. This is the system biasing itself toward what works. It's also exactly the mechanism by which surprise, from spec
43. Just the good part, though. Let's see. I was wandering 5 minutes ago. Becomes behavior change. Then I'll have it run some questions from both sets so far. We'll see. And then, because I want to get to MIM Evolve. That's actually the self-evolving memory. That's the whole purpose of everything else in between. thought I already clicked this.
Step 3. Run the metacycle, line 124 to 128. Hand the trace to midcam meta controller dot run underscore meta underscore cycle. The meta controller does its own 3-step pass. Monitor, look at the cycle. Assess, was anything off? Control, emit corrective control actions if so. The control actions feed back into how the next cycle will be configured. Big picture. This is the second loop, the one that wraps the first. The heartbeat is the cognitive loop. The metacycle is the learning from the cognitive loop. Two nested gears. The inner one spins fast and does the thinking. The outer one spins slow and adjusts the inner one. How an episode actually looks once it's stored. After all of this, here's what's in Neo4j for one heartbeat. A trajectory node tagged MIDCA cognitive underscore cycle heartbeat -42 ... containing 6 trajectory steps, 1 per MIDCA phase. For each goal that ended, a fact node like goal X equals achieved, valid underscore at equals T. A goal graph node updated to achieved, which already strengthened a basin. Concept and relationship nodes that the graffiti extraction pulled out of the phase outputs. Entities mentioned, relationships between them. Optionally, control actions emitted by the metacycle persisted as guidance for the next tick. That stretch of one heartbeat is now indexed, time-stamped, basin attached, and queryable. Your fully complete lap. A heartbeat fires, carrying a fresh clipboard. The creature checks consent. Fast brain looks. The referee gates. If needed, slow brain plans through a swappable provider. As each step finishes, it stamps a row on the clipboard. Perceive, interpret, eval, intend, plan, act. When the heartbeat ends, the clipboard becomes an episode. A bridge ferries that episode through the memory pipeline. It gets snapshotted, ingested as a trajectory, written as goal outcome facts, used to strengthen basins, and run through a metacycle that adjusts how the next heartbeat will work. The next heartbeat reads all of this. Repeat. You've now traced the full closed loop, including the part that makes it actually learn. What you've now seen 4 times. The same design pattern keeps showing up. Worth naming it explicitly. Sockets, not hard coding. Referee to providers. S2 to providers. Memory to graffiti service. MIDCA phases to registry config. You can swap the phase definitions without touching the heartbeat. Write as you go traces. Don't reconstruct at the end, stamp as you go. Best effort follow-up. Step 1, 2, 3 in the bridge each have their own try/accept. One failure can't break the heartbeat. 2 loops, not 1. Inner cognitive loop. Outer learning loop. The outer loop watches the inner loop and tunes it. You've now done the full lap with one of the deeper substructures. The cycle to episode pipeline opened up. Good places to come back for detail later. Attractor Basins / Hopfield Network. API/services/attractor_basin_service.py. The magnets that make basins do their thing. The meta controller. API/services/midca/meta_controller.py. The outer loop's brain. Goal graph plus goal monitor. API/services/midca/goal_graph.py. API/services/midca/goal_monitor.py. How goals are born, tracked, and ended. Question time, or want to keep going? I'd suggest you sit with the lap for a beat before another deep dive. The 4 patterns above are worth more than one more file traced.
Was MIM Evolve somewhere in there, or is that coming? Yeah, it was the inner and outer loop they should have. All right, let me start here then. I wanted to make sure. Take this here. And then I gotta take a break because this stuff is making my head bubble.
Yes, MIM Evolve was in there. Twice, actually. You met it without it being highlighted. First appearance in the memory pipeline lab as the second worker. I called it the adapter, the one with the no pre-chewed food rule. Its real name is MIM Evolve Adapter. The no predigestion rule comes from this thing's design philosophy. Second appearance in the cycle to episode lap as the destination of step one of the bridge. That line where the bridge calls adapter.ingest underscore trajectory, open parenthesis, request, close parenthesis, open parenthesis, cycle underscore memory underscore bridge dot py colon 184, close parenthesis. That's the bridge handing the cycles episode to MIM Evolve. What MIM Evolve actually is, in one paragraph, MIM Evolve is the trajectory layer. It accepts whole reasoning trajectories, a sequence of steps with observations, thoughts, actions, and turns them into something the graph can hold. It's the difference between a single fact and a story. Single facts can go through root underscore memory directly. Stories, like a full MIDCA cycle, go through ingest underscore trajectory. Same destination, Neo4j via Graphiti, different shape of input. Big picture. Think of MIM Evolve as the story-shaped door on the memory blanket. The router is the fact-shaped door. Both end up in the same warehouse. They just accept different package sizes. Where MIM Evolve sits in your lap, heartbeat arrow MIDCA, clipboard fills up arrow, finalize arrow, cycle memory bridge, vertical bar down arrow. MIM Evolve adapter.ingest underscore trajectory, vertical bar down arrow. Graphiti service, vertical bar down arrow, Neo4j. So when you see MIM Evolve, picture the part of the system that turns a trajectory of reasoning steps into something Graphiti can extract and Neo4j can store. There's also a separate term you'll see, MIM Evolve Protocol. That's the rulebook MIM Evolve enforces. Send raw, don't pre-extract, keep the lifecycle decoupled. It's mentioned in your Claude.md as anti-poison. The rules and the adapter are named the same thing because the adapter is what enforces the rules. One line distinction worth keeping in your head. Memory basin router equals remember this single thing. MIM Evolve adapter equals remember this whole episode. Graphiti service equals the only one with database keys. Nemori Riverflow equals look at recent episodes and distill what was learned. 4 workers. Each takes a different shape of input. All end up at the same vault. You're caught up. Want to keep going or pause for synthesis?
I want to go into the 4 elements of the MIM Evolve, and I want to look at, I know there's the Evolve Lab, and there's the Flash Searcher, which has the outside loop. I wanted to, in this context, touching base back with the information that we brought into it, the step through MIM Evolve and what it's doing. Also, LinOSS, what's the relationship that it has with MIM Evolve? LinOSS is oscillatory state space model, which is a bunch of like harmonic oscillators, and they are supposedly the longest. Like they're currently like long series of memory episodes with some element of pattern recognition that I haven't fully wrapped my head around yet. Good, you have the vocabulary down right. That's pandering or whatever. Oh crap! I thought this motherfucker was done. Okay, what am I doing to No, I was doing that on its own because I didn't move at all. I stopped touching it. Okay, patience. I have my hand ready to do the Control C. Yeah. Okay, so now we drop this off here. Okay.
Good. You have the vocabulary right. Evolve Lab is the modular taxonomy. Flash Searcher is the implementation repo it lives in. And yes, there's an outside loop. Let me ground this in what you already know. The big picture first.
Yo, he cleared his throat.
Everything we've been calling the memory system is actually one specific configuration of a more general design. MIM Evolve's whole point is don't hard code the memory architecture, evolve it. The system we walk through, router to adapter to doorman to editor, is one architecture. MIM Evolve is the framework that says, but maybe a different one would work better, and the agent itself should figure that out by trying variations. Big picture. Up to now, you've been looking at the memory system. From here on, you're looking at the system that changes the memory system, one floor up. The four elements,
Meta memory.
E/S/R/M, the genotype. A memory system, in MIM Evolve's view, is a four-piece genotype, like four genes on a chromosome. Mutate any one, you get a different memory system. 1. Encode. How does raw experience become structured? Take a raw trajectory of the agent's reasoning. What does it become? A summary? An embedding vector? An entity relationship extraction? An abstract syntax tree? That's the encode gene. In Dionysus today, encode is what MIM Evolve adapter.extract_with_context does. It sends raw text to Graphiti, which uses an LLM to extract entities and relationships. That's one encode strategy. A different one could be summarize to 200 tokens. Another could be extract only numerical values. MIM Evolve treats this choice as evolvable. Tieback. The no pre-chewed food rule you already know is a philosophical commitment to keeping encode pluggable. If you pre-extract entities before the adapter sees them, you've hard-coded a specific encode strategy upstream, and you can't evolve it anymore. The rule isn't about hygiene, it's about preserving the gene. 2. Store. Where does the encoded thing live? Vector database? Knowledge graph? Flat JSON? Hopfield network? An oscillator system? That's the store gene. In Dionysus today, store is Neo4j as accessed through Graphiti service. That's one store strategy. The basins, the Hopfield part, are a secondary store, sitting alongside the graph, holding what the system is paying attention to. Tieback. Remember the doorman with the only keys to the vault? That's a store implementation. MIM Evolve is saying the vault could be made of different stuff. A graph today, oscillators tomorrow. 3. Retrieve. How do you get things back out? Keyword, semantic similarity, predictive prefetching, hybrid search. That's the retrieve gene. In Dionysus today, retrieve is graffiti service.search plus fast recall service plus the Basin activation mechanism that biases the next heartbeat toward currently active concepts. 3 retrieval strategies running in parallel. 4. Manage. What do you do with memory over time? Prune, consolidate, forget, distill? This is the most interesting gene because it's where learning lives. That's the manage gene. In Dionysus today, manage shows up in 3 places. Nemori, the editor, distilling stretches of events into chapter summary facts. Basin strengthening when goals get achieved. You saw this in the bridge. Bitemporal invalidation, invalid_at, when facts stop being true. Big picture. Manage is sleep, the thing the system does between active tasks to keep the signal-to-noise ratio from collapsing as memories pile up over millions of steps. The 2 loops, the part you already half knew. MIM Evolve runs 2 loops. This is where outer loop comes from. Inner loop, experience evolution. The agent runs tasks using the current ESRM configuration, accumulating trajectories. This is the lap you trace through 6 prior conversation turns. Heartbeat fires, S1, referee, S2, memory, repeat. This loop's job is just to live. Outer loop, architectural evolution. A separate process called the meta-evolver watches how well the agent did, looks at success rate, token cost, latency, trajectory quality. Says things like, retrieval is too slow, encoding is dropping critical detail. Then it mutates one of the 4 genes, spawns a candidate child architecture, and tests it. Keep survivors. This loop's job is to redesign the inner loop. Big picture. This is evolution at the architecture level, not the parameter level. Most ML systems evolve weights. MIM Evolve evolves the shape of the system itself. That's why it's called meta-evolution. Flash Searcher is the high-throughput trajectory collector that feeds the outer loop. It runs huge numbers of agent rollouts so the meta-evolver has enough data to score candidates. In the current Dionysus Codebase, it's referenced but not yet wired in. See reference/integration-plan.md. The hooks are there. The wiring is the work. So where is MIM Evolve actually living in Dionysus right now? Honest answer, the.
Mm-hmm.
Honest answer? The encode/store/retrieve trio is wired. That's what the memory pipeline is. And the four-gene abstraction is named and respected. The codebase consistently treats these as separable concerns. But the outer loop, the meta-evolver itself, is not yet running. What's there? The provider abstraction at API/services/MIM Section 2.2 of the paper, Evolve Lab Provider Instantiation. The trajectory data model at API/models/memvolve.py:77. The comment literally says, Evolve Lab compatible. The webhook surface for receiving Flash Searcher trajectories, API/routers/memvolve.py. What's not there yet? The meta-evolver process that mutates architectures and benchmarks them. The diagnose and design agent that proposes mutations. Big picture. Same socket and plug pattern you've seen 4 times now. The outer loop has its socket built. The plug isn't installed yet. Now LIN-OSS. In this context, LIN-OSS equals linear oscillatory state space models. In one sentence, it's a candidate store implementation where memory is held as the state of a system of forced harmonic oscillators instead of as discrete entries in a database. The mechanical analogy. Imagine a wall of tuning forks of different frequencies. When events come in, they ring the forks. Some forks vibrate at slow frequencies. These hold long-term memory. Some vibrate at fast frequencies. These hold recent details. The whole pattern of who's ringing, how loud, is the current memory state. To recall something, you listen to the right frequency band. That's LIN-OSS. Why it's interesting as a store continuous, not discrete. Unlike a vector database with n rows, this is one continuous physical state, compresses infinite history. The math, second-order ODEs with stable damping, means it can hold a lot of context without blowing up or forgetting catastrophically. Fast. Parallel associative scans make it approximately 2 times faster than Mamba on 50,000 step sequences. Tunable. The oscillator frequencies and damping ratios are parameters you can change. Damp them less, and your memory horizon physically extends.
That's where I brought them together.
The relationship to MIM Evolve. This is the key insight. The OSE, Oscillatory Skill Evolved, proposal inspects/analysis context integrating memory LIN-OSS.MD is Evolve Lab gene plugged in with Encode MIM skill controller plus executor store. LIN-OSS oscillator state, retrieve. MIM skill retrieval skills plus readout hit. Manage MIM Evolve Meta Evolver, tuning the LIN-OSS damping/frequencies, plus MIM Skill Designer, evolving the skills. LIN-OSS is a specific candidate for the store gene. MIM Evolve is the framework that would evolve LIN-OSS's physical parameters to fit the task. If the agent can't recall something from 100 turns ago, MIM Evolve doesn't say, store more facts. It says, reduce damping on the long frequency oscillators so the memory horizon physically extends. The agent literally evolves better hardware. Big picture. This is the part that will make people lose their minds when it works. Most systems evolve what they know. OSE evolves the physics of how they know. The medium itself becomes adaptive. Where LIN-OSS shows up in the live code, you actually already met it in passing. Remember the convergence gate in MIDCA's interpret phase? Phase_registry.py:65 to 70.
That's my baby.
Interpret. Phase slot, open parenthesis, OODA underscore phase equals OODA phase dot orient, comma, description equals, quote, dtrack G DA colon anomaly detection plus knowledge integration, quote, comma, services equals, open bracket, quote, IAS incoherence analyzer, quote, comma, a distance detector. Convergence underscore gate equals true. Hash await lin OSS convergence before eval. That convergence underscore gate equals true is there because if lin OSS is plugged in as store, interpret has to wait for the oscillators to settle into a stable state before eval can read from them. Oscillators take a moment to converge after a perturbation.
Tune fork.
The MIDCA pipeline knows to pause for it. If lin OSS isn't running, the gate times out after 2 seconds and the cycle continues anyway. Linus underscore opacity underscore bridge dot py. Big picture. This is the cleanest example of the architecture being designed for future plugins. The phase pipeline already accommodates a store technology that doesn't fit the simple write and forget model. The slot is shaped for Linus, even though Linus isn't fully in the seat yet.
Hey, bye. I'm recording. Let me pause. So you guys.
You now have the full because memory operations aren't actually generic. How you remember a coding bug is different from how you remember a customer's preferences. Transactions hide that distinction. Skills make it explicit and learnable. Big picture. MIM Evolve evolves the house, the memory architecture. MIM skill evolves the muscle memory of how you walk through it. 2 time scales of learning, working on the same memory. The 4 parts of MIM skill 1. Skill bank, the library of routines. A skill is a structured textual entry with 4 fields. Purpose, capture temporal context. Trigger conditions, when inputs contain time series data. Application logic, extract dates and durations, link events on a timeline. Constraints, don't hallucinate specific dates. Tieback, this is exactly the shape of the Atlas lessons you saw injected before S2 in heartbeat_agent.py:1063. Each lesson says, in this context, this action worked/failed. That's a primitive skill bank entry. Dionysus is already using the pattern. In Dionysus, the skill bank is registered through MIM skill controller. Track 162 wired this. Each registered skill is a registered skill. mimskill_controller.py:52. 2. Controller, the policy that picks which skills to apply right now. When a memory operation needs to happen, the controller looks at the current context and selects the top K most relevant skills from the bank. It doesn't apply all of them, just the few that fit. Crucially, the controller is trained by reinforcement learning. The reward signal is downstream task performance. Did the agent eventually succeed at what it was trying to do? Skills that contributed to wins get picked more often. Skills that contributed to losses get picked less often. Tieback. Remember the referee in the heartbeat? Same shape. The referee picks S1 versus S2. The MIM skill controller picks which skills apply. Both are tiny policy networks doing low-stakes routing. Dionysus is consistent. Small policies for routing, big models for the actual work. In Dionysus, the controller lives at API/services/orchestration/mimskill_controller.py. 3. Executor. Runs the chosen skills over a span in one pass. This is the part that breaks with the transaction model most clearly. Traditional memory systems update turn by turn. Each new utterance gets stored separately. The result is fragmented. You lose narrative coherence. The executor, instead, operates on spans of interaction history. The controller picks top K skills. The executor takes a chunk of recent conversation, and an LLM applies all the chosen skills to the whole chunk in one generation. One pass, not many. Big picture. This is the editor reads a chapter, not one paragraph at a time. It produces coherent, distilled memory instead of a fragmented log. It's also dramatically more token efficient. Tieback. Remember Nemori's editor role in the memory pipeline? Distilling stretches of events into chapter summary facts? The executor pattern is a generalization of that. Nemori is one specific span-level operation. The executor framework would let you have many. 4. Designer. Evolves new skills when old ones fail. This is the closed-loop part. The designer monitors hard cases, situations where the agent had access to memory but still failed. You knew this and still got it wrong. Why? When a hard case is detected, the designer, an LLM, analyzes the failure trajectory and proposes either a refinement to an existing skill, capture temporal needed to also track durations, not just timestamps, or a brand new skill, track object location, coined in response to repeated failures in spatial reasoning tasks. Big picture. This is where the system literally invents new memory behaviors in response to specific kinds of failures. The designer is to MIM skill what the meta-evolver is to MIM Evolve. Same pattern, different layer. Designer refines the behaviors. Meta-evolver refines the architecture. In Dionysus, the failure detection front end is hard case minor. It feeds candidate hard cases into the designer's evolution cycle. The designer itself is referenced in the controller's docstrings as mimskill_designer.run_evolution_cycle. Parens. Track 162 spec this. The implementation is in progress. How MIMSkill closes the OSE loop with LinOSS. This was your earlier question, and now it's the right time to answer it cleanly. In the OSE proposal, LinOSS holds memory as oscillator state, continuous, infinite context. But oscillators don't speak natural language. They take vector inputs and produce vector outputs. MIMSkill
is the skill between symbolic intent, I want to remember when this happened, and oscillator perturbations drive the slow frequency oscillator bank. All right, let me pick up from here. Okay, I'm not going to sit through here and that, so I might as well see. Big picture, capture temporal skill in MIMSkill becomes a force function that drives low frequency oscillators in LinOSS. A capture activity skills drives high frequency oscillators. Okay, capture temporal versus capture oscillatory. The semantic intent of a skills map to a physical time scale in the oscillator bank. Symbolic meaning becomes physical resonance. This is the part of OSC that's genuinely beautiful when you sit and think about it. Okay, so I still got to build out my evolution. Okay, all this needs to be done still. How fast, precision, reinforcement learning. Okay, your full mental stack now. Okay, so this set needs to be revisited. Track 162. I remember reading that wasn't finished. Is the home of for all this and marked. Let's get in the plan. So is 162 marked as complete? Do we need to extract stuff from it and add it to conductor as a separate track? What do we need to do? Other than ignore me. Is 162 marked as complete? Okay. Let's do a pair review. Okay, cycle memory. Yeah, I should probably stop before my brain pop. I gotta go read marketing anyway.